Question 13 from Section 2 of the 2024 Higher Physics Examination from the SQA. The output from a signal generator is connected to the input terminals of an oscilloscope. The trace observed on the oscilloscope screen and the Y gain settings are shown. The time base setting is not shown. The frequency of the signal displayed on the oscilloscope is 250 Hz. You can see the diagram there, the sketch of the oscilloscope. Now, for 1 mark, it says state what is meant by the term alternating current, AC. Alternating current really means that the current is going one way in a circuit and then in the other way of the circuit continuously. And that's because it's manufactured that way. If I take you over to the PHET site, you can see we have a simulation of alternating current. It's produced in the industrial areas. It's produced with the power stations with large magnets rotating round so that the current goes in one direction and then goes in the other direction. In fact, we can show you the current changing. If I put in the current sensor here, you can see the current is going in one direction, then the other, one direction, then the other, one direction, the other. So the answer to that question is quite simply, alternating current is current which goes in one direction and then goes in the other direction in an electric circuit and is doing so continuously. Question 13 part B. Determine for 3 marks the RMS voltage of the supply. Well, we know to find the RMS voltage of the supply, that's VRMS, we have to find the peak voltage and divide it by the square root of 2. It's in the relationship sheet. The VRMS is the DC equivalent of an AC supply that would give the same heating or lighting effect. So what's the peak voltage in a supply here? Well, let's go and look it out. We go from the centre line up to the top and you can see it's 3 squares. So 3 divisions, and we look at our Y gain, it's at 5 volts per division, so we can work out what the peak voltage is. So the peak voltage can be calculated. V peak is going to equal to 3 squares high, or 3 divisions high, 3 divisions multiplied by whatever's on the Y gain, volts per division, and it's 5. So it's going to be 5 volts per division. So we just multiply those two numbers together and we can get our peak voltage. It's going to be 15 volts. Now that's 15 volts AC. To work out the VRMS, we just simply divide that by the square root of 2. So VRMS, as we said before, is V peak divided by the square root of 2, which equals 15 volts divided by the square root of 2, and we get a voltage RMS of 10.6 volts RMS. Question 13 continued part C. Determine the time base setting on the oscilloscope. That's for 3 marks. Now, to find the time base setting, we have to first of all work out what the period of that wave is. Remember, the period of a waveform is the time it takes for 1 complete cycle. And that's that time between here and there. You've got 1 complete up and then 1 complete down. That's a complete cycle. And the time taken for a complete cycle is called the period T. Now, we know the period T is related to the frequency of the wave by the following little formula. Period T equals 1 upon the frequency. And we're told what the frequency is. The frequency of supply is going to be 250 Hz. So, to find the time from here to there, that's the period, the time T is going to equal to 1 divided by 250 Hz. Now 250 Hz means 250 seconds to minus 1. And therefore we do our calculation as seconds minus 1 goes up to the top to give us seconds. And 1 divided by 250 gives us 4 times 10 to the minus 3 seconds. So we now know that that time interval from here to here is 4 times 10 to minus 3 seconds. And we also know we can change the 4 times 10 to minus 3 seconds into 4 milliseconds. So we can write that as 4 milliseconds to be in tune with the oscilloscope. So we know we're going to have 1, 2, 3, 4 divisions. So 4 divisions on the oscilloscope screen must be equal to 4 milliseconds. Therefore 1 division, it's a simple case of saying 1 division is going to be 1 millisecond. So the time base must be set at 1 millisecond to give us this display.